Imagine trying to point to the exact spot where the universe began. You can't. No matter which direction you point, you're wrong. The Big Bang didn't explode somewhere out there. It didn't happen at a specific location. The universe, the vast, intricate web of galaxies, dark matter, radiation, and empty space, has no center, no middle, and no edge. There's no special spot where it all started. That sounds impossible, I know. It clashes with every instinct your brain has. After all, if the universe expanded from a tiny point, shouldn't that point be the center? Shouldn't everything be moving away from some cosmic origin? That's what the word explosion implies. That's what the phrase Big Bang conjures. A bomb going off in empty space, debris flying outward. But that image is spectacularly wrong. I'm Leonard Susskind, and I've spent over 50 years studying the cosmos. Let me tell you, the absence of a center is not a minor technical detail. It's a fundamental truth that transforms our understanding of space, time, and the universe itself. Once you grasp it, you'll never view the night sky the same way again. Here's why your intuition fails. When you hear the universe is expanding, your mind instinctively imagines a balloon inflating, a bomb exploding, or people running away from a building. All of these scenarios have a center. The debris flies through space, away from a single point. But the universe's expansion isn't like any of these. Space itself is stretching. It isn't expanding into anything, it is the expansion. Every point in the cosmos moves away from every other point, not because objects are flying, but because the space between them grows. Consider this analogy. Imagine an infinite rubber sheet, not a balloon, but a flat sheet stretching endlessly in every direction. Now picture it being pulled uniformly. Any ant standing on that sheet sees every other ant moving away. The farther away an ant is, the faster it seems to recede. Each ant might think it's at the center. Every ant sees the same thing. No point is special. That's exactly what the universe's expansion is like, except in 3 dimensions, and it may be infinite. Now, let's clarify the Big Bang itself, because this is where confusion reigns. The Big Bang was not an explosion in space. It was an event in time. It was the moment when the universe was unimaginably hot and dense everywhere. Every cubic centimeter of space that exists now was dense and energized 13.8 billion years ago. If the universe is infinite today, it was infinite then too. The Big Bang happened everywhere at once. Every point in space can trace its history back to that instant of extreme heat and density. There's no cosmic closer or farther to the Big Bang because it occurred everywhere simultaneously. This isn't just theoretical. Einstein's general relativity predicts it. The Friedman equations describe it. And the cosmic microwave background, the afterglow of the Big Bang, confirms it. Around 380,000 years after that event, the universe cooled enough for atoms to form. Before that, it was a dense plasma, opaque to light, like a thick fog. Then electrons and protons combined into hydrogen atoms, making the universe transparent. Photons released at that moment have been traveling ever since, stretching into microwaves as space expanded. Today, the cosmic microwave background is almost perfectly uniform in every direction. That uniformity tells us the early universe had no center, no edge, no preferred direction. Even the tiny fluctuations in this cosmic background, about 1 part in 100,000, are critical. They seeded galaxies, clusters, and cosmic filaments. But these variations are random and distributed uniformly. No pattern points to a center. Statistical analysis matches predictions for a universe that has no edge and no central point. The geometry of the universe is not just an abstract idea, it's a consequence of general relativity. Matter and energy curve space, and the universe's overall shape depends on its total density. There are 3 possibilities. If the density is above a critical value, space curves like a sphere. It's finite but has no edge and no center, just like walking on Earth's surface, where every point is equivalent. If the density is below the critical value, space curves like a saddle, extending infinitely without a center. And if the density equals the critical value, space is flat, infinite, stretching endlessly in all directions, again with no center. Observations, especially from the cosmic microwave background and surveys of distant galaxies and supernovae, tell us that the universe is extremely close to flat within 0.5% of the critical density. That means space is either exactly flat or so nearly flat that any curvature is undetectable. Either way, there is no center. This is unsettling because humans naturally look for centers. We evolved in a world full of edges and boundaries where our position mattered, but the cosmos doesn't follow our instincts. The universe has no edge, no central throne, no privileged location. Earth isn't at the center of the solar system, the sun isn't at the center of the Milky Way, and the Milky Way isn't at the center of anything. No galaxy or supercluster occupies a special spot because no center exists. Now consider the observable universe, the sphere of space from which light has had time to reach us since the Big Bang. It has a radius of about 46.5 billion light-years. You might ask, wait, the universe is 13.8 billion years old. How can the radius be so much larger? The answer is expansion. Light travels through expanding space. A galaxy that emitted light 13 billion years ago has been moving away as the light traveled, and today it is about 46.5 billion light-years away. The observable universe is centered on us only because we are the observers. It's not a physical boundary. An alien in another galaxy would have its own observable sphere, overlapping ours but centered on their planet, seeing galaxies we cannot. No observer is at a cosmic center. This is reinforced by Hubble's law. Edwin Hubble discovered that galaxies recede from us at speeds proportional to their distance. At first glance, it looks like we're at the center of an explosion. But the same observation occurs from every galaxy. Step into Andromeda or a galaxy billions of light-years away, and you would see the same pattern. Every galaxy moving away, the farther they are, the faster they recede. This is not because there's a center, it's a natural consequence of uniform expansion. Think back to the rubber sheet analogy. Every ant sees every other ant moving away. The farther the distance, the faster the recession. Every point in the universe observes this exact pattern. No point is privileged. Expansion is homogeneous and isotropic, and that homogeneity is fundamental. This brings us to the cosmological principle, one of modern cosmology's foundational assumptions, confirmed with incredible precision. It states that, on sufficiently large scales, the universe is both homogeneous and isotropic. Homogeneity means it looks the same at every location. Isotropy means it looks the same in every direction. Together they ensure there's no center and no preferred direction. On smaller scales, the universe is lumpy: stars, galaxies, clusters, filaments, and voids. But zoom out hundreds of millions of light-years, and this lumpiness averages out. Galaxy surveys, like the Sloan Digital Sky Survey, have mapped millions of galaxies and confirmed this smoothness on vast scales. Philosophically, this is profound. If the universe has no center, we are nowhere special. For most of human history, people believed we were at the center. The Earth held the throne of the cosmos. Then, Copernicus moved us from the center of the solar system. Later, we realized our sun is an ordinary star in an ordinary galaxy. And now, we know there isn't even a center to be displaced from. Every location in the universe is equally fundamental. This might feel disorienting, but it's also liberating. Every point in the universe is as significant as any other. Wherever you are, that spot is just as central as the next. Our uniqueness doesn't come from our cosmic location, it comes from our awareness. Stars, galaxies, and dark matter don't ask questions about their place in the universe. We do. That conscious perspective, our ability to reflect on the cosmos, is what makes us extraordinary. Inflation is one of the most mind-bending yet elegant ideas in modern cosmology. Proposed in the early 1980s by Alan Guth, it describes a brief, unimaginably fast expansion of space in the first tiny fraction of a second after the Big Bang. During this inflationary epoch, the universe expanded by a factor of at least 10, Archelo, possibly much more. Imagine blowing up a balloon so quickly that it grows billions of times its original size in an instant. This rapid expansion solves several puzzles that puzzled scientists for decades. First, inflation explains why the cosmic microwave background, the afterglow of the Big Bang, is so uniform. Regions of space that seem completely disconnected today were actually in contact before inflation stretched them apart. That initial contact allowed energy to distribute evenly, leaving the smooth background we detect now. Second, inflation explains why the universe appears flat. Regardless of the universe's original curvature, exponential expansion drives it toward flatness, like inflating a balloon until its surface looks nearly flat in any local patch. Third, inflation predicts the tiny density fluctuations that seeded galaxies and clusters. Quantum fluctuations during inflation were stretched to cosmic scales, creating the irregularities that would grow into the cosmic structures we see today. But inflation also carries a deep implication for the question of cosmic centers. Our observable universe, the region we can see, is just a tiny patch of a vastly larger cosmos. Imagine the universe as a balloon inflated to an absurdly enormous size. The observable patch is like a postage stamp on the balloon's surface. It looks flat and uniform, giving the illusion of simplicity, but it is only a small fragment of the larger whole. In that larger space, every patch looks the same. There is no center, no edge, no point that is more fundamental than any other. Our patch of space is not special. It is one of countless regions, each obeying the same laws of physics, each with the same density and temperature. Some people point to the cosmic microwave background's slight dipole anisotropy, a tiny difference in temperature in opposite directions, and wonder if it defines a special location. It doesn't. That anisotropy comes from our motion relative to the rest frame of the CMB. The Earth, Sun, and Milky Way are moving at roughly 370 kilometers per second relative to this rest frame. This motion causes a Doppler effect, making the CMB slightly hotter in the direction we're moving toward and cooler in the direction we're moving away from. Once we subtract this motion, the CMB is isotropic to 1 part in 100,000. This is a velocity, not a position. It tells us how fast we're moving, not where we are in the universe. Inflation also opens the door to a larger, even more mind-expanding idea, the multiverse. If inflationary theory is correct, our universe could be just one bubble in an infinite sea of bubble universes. Each bubble emerges from different conditions in the string theory landscape, potentially with different physical constants, particles, or forces. In this picture, asking where the center of our universe is becomes meaningless. We are a single bubble in an infinite foam. Each bubble repeats the same pattern: no center, no edge, uniform conditions. The concept of a cosmic center dissolves entirely, replaced by a democratic, uniform cosmos where every point is as central as every other. And yet, this has profound philosophical consequences. Think about your location. You're on a small, rocky planet orbiting an ordinary star in an ordinary galaxy. Our galaxy is just one of roughly 2 trillion in the observable universe. Stars alone number around 10, a trillion. And every single star, planet, and atom in the universe exists at a location just as central as yours, because there is no center. This doesn't make us insignificant. Our significance comes from awareness, from consciousness. We are matter arranged to observe, question, and understand the universe. Stars and galaxies don't reflect on their position they exist, but only we can marvel at the cosmos. Finally, the universe's lack of a center conveys a beautiful symmetry. It is profoundly democratic. No civilization, if other civilizations exist, occupies a special location. Every observer sees the same large-scale universe, the same expansion, the same cosmic background temperature, the same laws of physics. There is no privileged frame, no cosmic throne exists. The laws of physics are universal and geometric, applying everywhere equally. This realization is not just scientific, it's philosophical, shaping our understanding of reality itself. Now let's dive even deeper into the mind-bending geometry of the universe. Even if you accept that the universe has no center, you might still wonder if exotic shapes or topologies could change that. Physicists have explored models where space wraps around itself like a donut or a torus. In such a universe, traveling in one direction long enough could eventually bring you back to your starting point. But here's the crucial insight. Even in these bizarre shapes, there is still no center. A torus has no middle point, no edge, no distinguished location. Every point is just as central as every other. Other possibilities include more complex shapes like a Klein bottle or other compact topologies, which also have no center. The universe might be finite but unbounded, a shape that curves back on itself in ways we can barely visualize. Even if space has such a structure, our observations of the cosmic microwave background, the distribution of galaxies, and the laws of physics still point to the same conclusion. There is no central point where the universe began. The absence of a center survives every model, every shape, every variation in geometry. It is a robust, universal truth. This leads to a profoundly unsettling yet beautiful conclusion about our place in the cosmos. When you look at the night sky, resist the natural urge to imagine yourself at the center. You are not. You're not on the outskirts either. There is no cosmic reference point from which to measure your position. You are here, in your own patch of space, composed of atoms forged in ancient stars, standing on a rocky planet orbiting an ordinary star, in a galaxy among trillions. And this patch, right now, is just as central as any other. In a universe without a center, there is no hierarchy of locations. Every point is equally fundamental, equally significant. Think about the Big Bang in this context. Many people picture it as an explosion, a point in space where everything began. That's wrong. The Big Bang was not a place, it was a moment. It occurred everywhere simultaneously. The ground beneath your feet existed at the Big Bang, compressed to unimaginable density, hotter than the center of any star, 13.8 billion years ago. Every point in the universe shares this history. Every location you can imagine traces its existence back to that same cosmic origin. You are, in a literal sense, standing at the site of the Big Bang, and so is every other point in the universe. Now, let's turn to something even more astonishing, the observable universe. The sphere of space we can see is centered on us simply because we are observing it. It extends roughly 46.5 billion light-years in every direction. That might seem confusing at first. After all, the universe is 13.8 billion years old. Shouldn't the observable universe be smaller? The key is that space has been expanding as the light travels toward us. The galaxy that emitted that light has been moving away the entire time, so the distance now is far greater than the travel time multiplied by the speed of light. An alien in a galaxy billions of light-years away has their own observable universe, centered on them. We are not central in any absolute sense. We are central only in our own observational horizon. This brings us back to Hubble's law. Discovered in 1929, Hubble observed that galaxies are moving away from us, and the farther a galaxy is, the faster it recedes. At first glance, this makes it look like we are the center of expansion. But the same pattern is seen from any galaxy. Every observer, wherever they are, sees the same recession velocities proportional to distance. There is no explosion from a point. The expansion is uniform, homogeneous, and isotropic. Every location sees itself at the apparent center, but no location is truly central. The universe's expansion is built into space itself, not through space. Finally, we reach one of the foundational principles of cosmology, the cosmological principle. It states that on sufficiently large scales, the universe is homogeneous and isotropic. Homogeneous means it looks the same at every point. Isotropic means it looks the same in every direction. Together, these principles guarantee no center, no preferred direction. On small scales, the universe is clumpy, full of stars, galaxies, clusters, filaments, and voids. But when we zoom out hundreds of millions of light-years, this lumpiness averages out. Observations, including the Sloan Digital Sky Survey, confirm that the universe is remarkably uniform. There are no edges, no walls, no centers. Next, we will explore what this means for human perspective, how a universe with no center transforms our understanding of significance, and why our place in the cosmos is far more profound than any throne or middle could ever be. So, what does it mean for us, personally, that the universe has no center? For most of human history, we imagined ourselves at the cosmic center. The Earth was thought to be the pivot around which the heavens revolved. Our significance was measured by our place in the cosmos. Then Copernicus taught us otherwise. Earth was not the center of the solar system. Later, we learned the sun is just one ordinary star in an ordinary galaxy, and that galaxy is one among hundreds of billions. And now we discover there isn't even a center at all. The throne we imagined, the cosmic seat of importance, never existed. Every point is equally fundamental, every location as central or as peripheral as any other. At first glance, this can feel unsettling. It challenges our natural instincts and our psychological need for a center, a place that matters above all else. But there is another way to interpret it, an empowering way. Our significance has never come from our location in space. It comes from awareness. We are, as far as we know, the universe reflecting on itself. Our brains, our thoughts, our questions about existence, these are what make us extraordinary. We are conscious matter capable of contemplating the very cosmos that surrounds us. Stars, galaxies, and dark matter don't question their place in the universe. We do. And that, in a sense, is far more remarkable than being at any central point. Now, let's talk about inflation, a theory that explains why the universe looks and behaves the way it does. In the early 1980s, Alan Guth proposed that the universe underwent a brief period of exponential expansion, a tiny fraction of a second, during which space expanded by a factor of at least 10^26. This sudden inflation solves many puzzles. It explains why the cosmic microwave background is so uniform, why the universe is so flat, and how the tiny fluctuations that eventually became galaxies arose in quantum processes. But inflation also reinforces the idea of no center. Our observable universe is just a tiny patch of a much larger universe, much like a small flat region on the surface of a vastly inflated balloon. To us, that patch seems flat and infinite, but the larger structure might curve or extend in ways we cannot detect. Every patch, every region, has the same properties, the same density, the same laws of physics, the same history. There is no preferred location, no central patch, no home base of the cosmos. Our observable universe is a postage stamp on a surface unimaginably vast, and we happen to occupy one corner of that stamp. Even the cosmic microwave background, the afterglow of the Big Bang, reinforces this view. It is remarkably uniform in every direction, showing no pattern, no bullseye, no signature of a central explosion. Tiny fluctuations exist, yes, but they are random, uniform, and consistent with the predictions of inflationary cosmology. The slight dipole anisotropy you might hear about the difference in temperature across the sky is due to our motion relative to the cosmic rest frame, not a central point in space. It tells us how fast we are moving, not where we are in the cosmos. And here's where it gets even more mind-bending. If we consider the multiverse, a concept tied to inflation and string theory, our universe might be just one bubble among an infinite sea of bubble universes. Each bubble could have its own physical constants, its own particles, its own laws of physics. Asking where the center of our universe is becomes absurd in this context. There is no center in the bubble foam, no edge, no privileged location. Our cosmic neighborhood is a single bubble in an endless, inflating sea. So, when you look at the night sky, recognize this. You are in a place that is neither central nor peripheral. You are at every point in the universe at once, because every point shares the same cosmic origin. And that's profoundly beautiful. Our location doesn't diminish our significance, it amplifies it. We exist not as passengers on a central stage, but as observers capable of understanding the universe, capable of asking questions about its structure and history, capable of appreciating its vastness and its elegance. Next, we will conclude by tying together all these threads: the Big Bang, cosmic expansion, inflation, the multiverse, and explore the ultimate philosophical takeaway: why understanding the universe's lack of a center transforms the way we see reality itself, and why it makes every one of us just as important as any point in the cosmos. So let's bring everything together. The universe has no center, no edge, and no privileged location. The Big Bang was not a spot in space, it was an event in time, a moment when the universe was hot and dense everywhere simultaneously. Every point in space can trace its history back 13.8 billion years, back to that same searing, compressed state. Inflation stretched space so rapidly that our observable universe is just a tiny, nearly flat patch of something unimaginably vast. The cosmic microwave background shows uniformity in every direction. Galaxies recede according to Hubble's law from every vantage point. Observers anywhere in the universe see the same cosmic expansion, the same laws of physics, the same large-scale structure. There is simply no central point to claim as special. This reality can be deeply humbling. For centuries, humans believed they were at the center of creation, that their world and their planet had cosmic significance simply by being a focal point. Now, science tells us otherwise. Yet there is a profound and even inspiring truth hidden in this revelation. Every location in the universe is equally central. Every observer, every planet, every star is part of the same grand cosmic tapestry. Your location does not diminish your significance, it liberates it. You are part of a universe that is not centered around anyone, and yet you have the unique capacity to understand it, to witness it, and to appreciate it. That awareness, that consciousness, is the ultimate measure of your place in the cosmos. Think about it. Earth is just one of billions of planets orbiting hundreds of billions of stars in our galaxy, which is itself one of trillions of galaxies in the observable universe. And yet, because of our awareness, because of our curiosity, we occupy a position in the universe that is, in a very real sense, extraordinary. The universe's lack of a center doesn't make us insignificant, it makes every observation, every insight, every question we ask about the cosmos equally valid and equally central. And the story doesn't end with our observable universe. If the inflationary multiverse is correct, our universe is just one bubble among potentially infinite others. Each bubble may host different laws of physics, different constants, different structures. Asking where the center is in such a multiverse is meaningless. There is no bubble at the center, no privileged vantage point, no cosmic throne. Every bubble, like every point within a bubble, shares the same fundamental status. It is simply one piece of an unimaginably vast and dynamic reality. So what do we take away from all of this? First, the universe is not designed around our expectations or psychology. It is not centered on us or anyone else. Second, our value does not come from location, position, or privilege. It comes from the remarkable fact that we can understand.